Hello everybody, and welcome to the next video of the course. In this video we will revisit if statements or conditional statements, and I just want to talk about a couple of other things you can do with them. So first I'm going to introduce the words and or in conditional statements. These are English terms but also Python logical terms. And then I'll introduce nested conditionals, which basically just means that you can put an if statement inside of an if statement if you would like. So I'll show you some examples of that. So let's start with the English and Python words, and or. Before I do that, I need a definition. A Boolean expression, that's what I'm defining here, is a statement that is either true or false. So here's a Boolean statement. 2 plus 2 equals 4. That's a true statement. 3 minus 1 equals 7. That is a false statement. X greater than 9 is either true or false depending on the value of x. You know, if x is 30, then that is true. If x is 5, that is false. However, this is a statement that is either true or false, depending on what x is. Here's another statement, x plus y less than or equal to 30. You know, that's true or false, depending on the values of both x and y. DTS 190 is your favorite course this semester. That's true. Dr. McCune is the best human you know. Also true. You know, so a Boolean statement or expression is just something that's either true or false. Here are some examples of non-Boolean expressions. Hi, right? That's just a greeting. You can't put a truth value on that. Any sort of question, you know, what school do you go to? Yeah, it's not a true or false statement. Up here I had x greater than 9. What about just the statement x? It's hard to put a truth value on that, you know. So you're not actually comparing x to something or whatever. There's no way to call this statement true or false. Okay, so what's the point of this definition? Well, recall that in Python when you write something like, hey, if, and then you put a condition there, you know, and the conditions that we had were like if x is equal to 10, or if y is less than 5, things like that. Whatever you write in this blank spot right here must be a Boolean expression. It must be a statement that is either true or false. And if the statement's true, Python will do what is inside the if. If that statement is false, Python will move past and move down to the next else if, or to the else, or wherever it happens to move down to. However, if what you put in this blank is like, hi, Python will not know what to do with that, okay, because it can't check whether that's true or false. Okay, so anytime we do an if statement, and then later when we do loops, we'll get to those in a couple of weeks, you need a Boolean expression here to check against, to see whether or not you're going to do the code that follows. Okay, so now we can define and or in a Python and logic sense. So suppose x is a Boolean expression, and so is y. You can create another Boolean expression like this, x or y, and x or y is true, so it has truth value true if either x or y, or both, are true. So if x is true, or y is true, or they're both true, then x or y, the Boolean expression, is also true. So just for example here, if x is this, capital X is this expression here, little x less than 6, and capital Y is the expression little y is equal to 7, then x or y is this expression here, little x less than 6 or little y equal to 7. So this compound statement here is true if either x is less than 6 or y is equal to 7. So for example, if x is equal to 4, y is equal to 8, well, 4 is less than 6, so this left-hand part is true, therefore the overall statement is true. If x is 3 and y is 7, for example, now both of them are true. So the overall or statement is true. Okay, so anyway, the only way that this statement here breaks, the only way it's false, is if both pieces are false. So if x is 10, for example, now the left-hand part breaks. If y is 9, the right-hand part also breaks. Then that's what makes this or statement false. So now let's move on to the word and in logic. If x is a Boolean expression and y is also, then the statement capital X and capital Y is also a Boolean expression. X and Y is true only if both X and Y are true. Okay, so for an or statement to be true, you only need one hit, either the left or the right, or both, have to be true in order to get overall truth on the or statement. With an and statement, it's much harder for that to be true. This is true if and only if both x and y are true. So here are the two expressions from before, x less than 6, y equal to 7. So if you stick an and in between, you get this compound statement here, x is less than 6 and y is equal to 7. This statement is true if and only if x is less than 6 and also y is equal to 7. So if x equals 4 and y equals 8, that Boolean expression is false. Recall, right, if there was an or right here, then x being 4 and y equals 8 caused truth, right, because you only had to satisfy left or right. But with x being 4, we satisfy left. With y being 8, we break this right-hand part. So again, an and statement, it's much harder to be true. You have to fulfill all the conditions here. So for example, if x equals 2 and y equals 7, you've satisfied both conditions, so the overall statement is true. Okay, now in Python, when you want to translate the word and, you can just literally write and the word or is also written or. So that works out for us, you know. So the logical English word and is the Python and same thing for or. So for example, here's some sample Python code. This is using the input code we used last time. So suppose you ask somebody their name. So you prompt them with a question, you do this input command, and then recall this str means string. So what you are expecting from the user is to give you a string of English. That's a reasonable expectation if you ask them what their name is. And then the result is stored in this response variable here. Okay, so this is something we saw last time, so I'm not going to review it anymore. So response now could be anybody's name, but suppose it's my name, right, David. But suppose I don't care about like capitalization or I'm lazy, right? Then, you know, I could write David with a capital D. I could also write David with a lowercase d. And suppose that in either case, you want this program to tell me hi, you know. You can just set up an if statement like this. If the response is equal, and recall here inside if statements, we need a double equals. If the response equals David with a capital D or response equals David with a lowercase d, then I print this welcoming message. Okay, so notice what's kind of nice about this is that this Python if is pretty close to what we'd say in English. It's not exactly English, right? But if response equals David with capital D or response equals David with lowercase d, you know, colon, then do something, right? What I want you to do is print a greeting message. Okay, so notice I have written this in what seems like kind of a clunky way in the following sense. In English, sometimes we would say this: if the response equals David or David. We sort of skip the second part here, right? If what they told me is David or David, then print hi. In Python, you actually have to restate the equality condition. So if the response is David or the response is the other David. Okay, so you can't erase this right here. You can get rid of this in English, right? If what they told me was David or David, you know, but you can't do that in Python. Okay, it's also worth pointing out that you can just keep oring all you want. You can just keep adding on that word if you want to. So suppose you ask them a question like this: do you want this program to keep going? So this is the kind of question you might ask in a game program. You know, do you want to keep playing or do you want to quit? That kind of question. Okay, so same thing. You grab the response from them. It's a string, presumably, because they're going to enter something like yes or no, and you save the response in this response variable. Well, now, you know, it's kind of hard to know how people might answer. Presumably, you want them to type yes like this, capital Y, lowercase es, but they might do other things. They might just do all lowercase yes. They might just type a capital Y. They might just type a lowercase y. They also might type yes in all caps, which is a condition I didn't put here, but you could put there also if you wanted. So anyway, if you read this out loud, if response is yes with a capital Y, or response is yes with a lowercase y, etc. You know, if any of those things happens, then you tell them, all right, we'll keep playing, or whatever. Okay, so here's some sample code with Python with an or in it. Okay, so now let me move on to De Morgan's laws. These laws come up when you're dealing with ands and ors, in particular when you're doing things like what's on this slide here. So suppose you want the user to enter either yes or no in response to a yes-no question you ask them, just like this, right? You want to keep going or not? Well, suppose the user is either being difficult, or they're just doing something on accident, they enter something else. Right, so they enter a T. A T is right next to a Y on the keyboard, right? So they've mistyped. So when they enter something invalid like that, presumably you would like your program to deal with that. You'd like your program to give them a chance to fix what they typed. So here's some code like that, okay? Or this is pseudocode. We're going to have to translate this into Python in a second. But this is mostly Python. So play the game, yes or no, right? So now, response being yes or response being no, that's what you want from them, right? You want them to enter either a yes or a no. Well, what if they don't do that? What if not that, right? Then what do you want them to do? What you'd like to do is say, try again, right? So play this game or not, like just do the same command, right? And sorry, I should have deleted this. You don't even need this line right here, okay? So if you're following along with code in your own compiler, you don't even have to. You don't need more input from them. You can just tell them invalid input. So just print this. Okay, anyway, so if not one of the two valid inputs, then they should enter another one, right? Give them a chance to enter yes or no. So De Morgan's laws let you deal with this not right here, okay? So here I have an or statement. What if they don't do that? What if they not that? How do you do that in Python? So in other words, how do you apply the English word not to an or statement? And if you need to, right, how do you apply the English word not to an and statement? De Morgan's laws exist to deal with that. Okay, so in Python, the word not, the English word not, is written as an exclamation mark. So as we've already seen, exclamation mark equals means not equals in Python. That was in a previous video. So De Morgan's laws say this. Not x or y actually becomes not x and not y. So if you not an or statement, what does it become? It becomes an and statement. And then you end up knotting the individual pieces of the statement. If you not an and statement, it becomes an or statement, where again you apply nots to both the individual pieces of the compound statement. Okay, so how does this play out in the example we just have? Well, if what you want is either a yes or no, and they don't do that, right? They not that. Then De Morgan's law says, okay, well, change this or to an and. So notice there's an and there. And also negate both of these statements, right? So not capital X, not capital Y. So to negate this statement here, response equals Y, the opposite of that, the not of that, is response not equal to Y. So there's response not equal to Y. And the opposite, or the negation of response equals n, is response not equal to n. So in Python, we can write the following code like this. This is now pure Python code. Okay, so get the input from them. If their response is not equal to yes, and also their response is not equal to no, then force them to give you another response, right? Here's that same command, just make them do it again. Okay, so here's a brief intro to and or statements. So the main takeaway from this is that you can do code like this. If you want multiple conditions to check on an if, you can just slap an or in between. If you need a bunch of things to be true all at once, you can plop an and in between. Okay, so now let's move on to what are called nested conditionals. So putting if statements inside of if statements. So this first part of this little picture I have here, this part here, this if, elif, else, we had a picture like that when we talked about what a conditional is. So when the program gets to a spot where you have like an if-else structure, you are giving the program different branches it can go down, but they're mutually exclusive. So you can only go down one of these branches. You can go down the if branch maybe, the else if branch maybe the else, but you can't go down more than one of them. Okay, so here's the thing. If the program can branch like this, well, once it's inside a branch, there's nothing stopping it from branching again if you want it to. So inside of this if, you could have another binary choice here. Inside this else if, you could have a choice like this. Inside this else, you could have a three-way choice. So in other words, the picture I had before was just a sort of one-level tree right here, like where you offer it different branches up front, like a menu of options or something. Well, once you're inside of a branch, you can branch again if you want to. There's nothing stopping you from doing that. So let me hop over to the compiler and show you an example of that. So here's all the code. So if you would like to type it on your own, I would suggest you do so you can play around with it. But the main takeaway here is to notice that there are ifs inside of ifs, and to also notice the indentation structure here. Okay, so let's just start at the top and talk through what is happening here. So first of all, I create a variable x and give it a value of 10. That's arbitrary. I'm going to change the value here in a little bit. Now at line 11, the program gets to this statement. If x equals 10, then do something. So since x is indeed 10 in this code, it will print x is 10. And then as we discussed before, what do you have here? You have an if, else structure. So if it goes down this branch here, print x equals 10, then when it's done, the program will hop right down to line 26, right? Because you can only do one of these little branches. So if I run this code, it tells me x is 10, and it's done. Okay. Well, what if x is 12? Well, 12 is not 10, so at line 11, when the program encounters this, it will not go down this branch. It won't go down this path of the program. It won't print x is 10. However, 12 is even. So in other words, when you divide 12 by 2, you get 0 remainder. Recall this percentage operation from before. So when you do x percentage 2, what you are doing is dividing x by 2 and seeing what the remainder is. So 2 evenly goes into 12, so the remainder is 0. So what I'm saying here is Python doesn't do this because x is not 10. However, 12 is even. So now Python does go to line 14, and it will print x is even. Now Python is on line 15, and now it says, oh, well, if x is 12, then print x is 12. Otherwise, print that x is not 12. Okay, so again, what do I have here? I had an else if right here. I put an if inside of it. You can do that, you know. Now, since this print statement here is inside of this if here, this if x equals 12, notice I've indented again. So this print x equals 12 has been indented twice. It's inside this else if, so it has to be indented once to reflect that, and it's also inside this if right here. So now if I run this program, what happens? I go down this line 13 branch, so I'm going to print x is even. And then if x equals 12, it's supposed to print x is 12. And notice it does. Right? Otherwise, it's supposed to print x is not 12, but the otherwise doesn't kick in because x was 12. Now if I change the value to 16, what do we think is going to happen? 16 is still even, so I'm still going to go down this branch of the program. But now x is not 12. So now I'm going to hop to this otherwise branch. It should print x is not 12. And that's what it does. It tells me x is even, but x is not 12. Okay, well, suppose x is like 35 or something. Well, 35, not 10, so I don't go down this branch. 35, not even, so I don't do any of this stuff between lines 14 and 18. That's its own separate branch when x was even. So I'm going to go to the catch-all else statement. Now I hop down here to line 20. So if x is bigger or equal to 30, I print high. Okay, you can tell my creativity is running out here in terms of what I print in the output box. Anyway, if x is bigger or equal to 30, print high. Otherwise, if x is bigger or equal to 20, print there. And then otherwise, print students. So if I run this, it goes down this else branch, and then it goes down this if branch, and then it's done. So now it's at line 26. What if I put 25 right here? If I put 25 right there, that's not 10, that's not even. It's also not bigger than or equal to 30. However, it is bigger than or equal to 20. So when I run this, it just prints the word there. And then finally, if I put like a 19 here, 19 is not 10, not even. It's not bigger than 30, not bigger than 20. So I fall into this last little branch down here. It just tells me students And again, once it's done with all this, so you've given it 3 possible paths to go down here. Within this path, you've given it 2 options. Within this path here, you've given it 3 possible options. Once it's done with all that, now it just hops down to line wherever it comes next. So if it goes down this else if branch, so let me make it go down the else if branch again. If it goes down the else if branch, it does what's inside there, whatever you tell it to do, and then it hops to the end of the entire structure. It did the else if thing, therefore it can't do the else thing. So it will hop down to line 26. There's nothing there. It will continue on to line 27, and it prints 5 plus 10, which is 15. So the program just keeps on rolling after it encounters something like that. So that's what I mean by nested conditional. I had ifs inside of ifs. So you can do that, is what I'm saying. Okay? And why would you want to do that? It seems sort of, I don't know, complicated or convoluted or something. Why would you need a structure like this? Well, here's just one example. Okay, there are many you could come up with, but suppose you've written a program, and of course, this is hypothetical. We don't have the tools to do this right now, but whatever, you're a gaming programmer. You've written a program that when you open it, it will let you play either chess or checkers. And furthermore, each game comes with a hard mode or an easy mode. So, how do you let the user decide what they're going to do? You have to let them choose a game. You have to let them choose a difficulty mode. So here's just a schematic. Okay, so this is all pseudocode because again, we don't have chess code. Okay, we don't have the tools to program a chess game. But anyway, here's a kind of scheme you could do. You could say, well, look, user, enter 1 for chess and 2 for checkers, and grab that from them. So I put an int here because they're supposed to enter an integer, right? 1 or 2. These are numbers. If the response is 1, they've told you they want to play chess. Okay? Well, once they've told you they want to play chess, now you need to know whether they want easy or hard. So now, within this branch of the program, the chess branch, right, you can tell them enter 1 for easy and 2 for hard. So now, response means something different, right? You're overriding the original response. So this original response could have been 1. Now it can be 2, right? You're giving it a new value. Anyway, if they say 1 again, then right here would go all your code for easy chess. However, if they enter 2, or anything else actually, right, the way this code is set up, right here goes your hard chess. So here's a pretty natural way in which you might expect to see an if inside an if. Anytime you're sort of like progressively getting more information from somebody, right? Well, first of all, make this choice. And once you've made this choice, now make another choice, right? You're just letting them choose different paths the program can go down, much like in this picture, right? So imagine these 2 branches are chess or checkers, right? And then once you're inside the chess branch, easy or hard. Once you're inside the checkers branch, easy or hard. You know, that's the kind of structure you would need. Now, so I didn't write else if here, but you could if you wanted to. It doesn't matter. Else if the response is 2, so now they've chosen checkers, then again, ask them the same question you would for chess. Do you want the easy or hard? And if they give you a 1, we're telling them that means easy, so your checkers easy code would go right here. Otherwise, if they don't enter a 1, your checkers hard would go there. Okay, so that's a pretty natural way in which you'd expect to see nested conditionals. So at the end of this video, hopefully you are now comfortable with and or in Python, what those words mean, and you have some level of comfort with putting if statements inside of if statements. And again, if I were you, I'd be following along with the code while you're watching this. Hopefully you fiddled with this some, right? Play around with this. Play around with the value of x. Add another branch down here. Right inside this if branch, I didn't have any multiple paths. Put an if structure inside here or something, right? Just play around with it and see what you think.